guys, welcome to lesson 1 of Unit 5, Exponential and Logarithmic Functions. So to start off, we're just going to kind of quickly go through some exponent law review. So remember, the product law is when you have when you're multiplying two bases that are the same, then you just add the exponents together. When you're dividing two bases that are the same, you subtract the exponents. The power law is when you have a power raised to another power. So what you would do in that case is keep the base and multiply the two exponents together. The power of a product rule states that when you have a monomial with multiple bases inside of it, the exponent on the outside applies to everything on the inside. So for example, if you had let's say 3a to the power 5. That all raised to the power of, let's say, 2. Well, what you would do is take the 3 and raise it to the power of 2, and you would take the a to the power 5 and also raise that to the power of 2. So what you would end up with in this case is 9a to the power of 10. Okay, so do not confuse this with when you have binomials inside of your bracket. So for example, if you had a plus b to the power of 2, that is not the same thing as raising each thing to the power of 2. Okay, so it only works with monomials. The zero exponent, basically anything raised to the power of 0, is 1. Power of a quotient, so if you have a fraction, the exponent on the outside is applied to both the numerator and the denominator. And negative exponents basically change your base going from the numerator to the denominator, and it works vice versa. So if you had, let's say, 1 over a to the power of negative m, well, that negative exponent, it brings it up to the numerator. If you have a fraction with a negative exponent, basically what you can do is just take the reciprocal of that fraction, so b over a, and then raise it to the power of the positive exponent. And then again, recalling the rule from above, that each numerator and denominator will get raised to that exponent. And then finally, we have rational exponents. So a to the power of m over n. Notice that this does become a radical. So the denominator becomes the root, and then the numerator becomes the exponent. So there are two ways that you can deal with this question. So you can take your base, raise it to the exponent m, and whatever that answer is, take the nth root of it. Or you can take the nth root first of the base and then raise it to the power of m. Either way, you'll get the same answer. So what we'll do now is apply some of these rules. So we're going to simplify. Generally, what you want to have is positive exponents. So we're not going to leave any negative exponents there. Bedmass rules apply here. So basically, I have an exponent 2 on the outside of this bracket. So we're going to work with that bracket first. So I'll leave the 7a squared b cubed. And then basically that exponent 2 affects the 2, the a cubed, and the b. So 2 squared would give you 4. The a cubed squared gives you a to the power 6. And then b to the power of 2 is just b squared. Okay, when you get to this point, it's just numbers times numbers, letters times letters. So 7 times 4 will give us 28. A squared times a to the power of 6. Remember, when you're multiplying with the same base, you keep the base and then add the exponents. Same with the variable b, so b to the power of 5. And that would be our final answer. Okay, moving on to question B. It's the same idea as multiplying. All you're doing is numbers divided by numbers and letters divided by letters. So 20 divided by 5 gives us 4. A to the power of 4 divided by a to the power of negative 2. Remember, when you're dividing, you keep the base and then subtract. So 4 take away a negative 2 gives us the power of 6. We'll keep the base b, and then the exponents, 5 take away 6 And then C, negative 2, take away negative 2 will give us to the power of 0. Okay, so again, recall that we're leaving all positive exponents. So we'll leave the 4 and the a to the power of 6 as is. Now, because the negative exponent is only touching the b, that is going to flip and go down into the bottom. So that becomes b to the power of positive 1. And then c to the power of 0, well, that is really just 1. So basically, we're taking this expression here and multiplying by 1. So our final answer would be 4 a to the power of 6, all divided by b. Okay, for part C, very similar to what we did in the first question, each one of these bases will be raised to the power of 3. So 2 to the power of 3 is 8. A cubed to the power of 3. So power to a power, we multiply. And then same for variable b. Negative 4 to the power of 3 ends up being negative 12. So our final answer here would be a to the power of 9. And then because the b has a negative exponent, we'll flip that into the denominator and then make it a positive exponent. Question D. There's two ways that we can tackle this question. So basically this whole expression here is raised to the power of negative 2. So you can flip it right away and say that this is 1 over 3 a to the power of 4 b to the power of negative 5, all raised to the power of positive 2. And then we can work accordingly. So 3 to the power of 2 will give us 9. A to the power of 4 squared. So we'll multiply the powers together. And same with the b. So b to the power of negative 5 and then raised to the power of 2 will give us negative 10. Now again, we have a negative exponent here. So b is the only one that has a negative exponent. So it's going to get raised up into the numerator. B to the power of positive 10. And then everything else will stay as is. Okay, the other way to tackle this question is to recognize that each one of these bases will be raised to the power of negative 2. So essentially it's really 3 to the power of negative 2 times a to the power of 4 raised to the power of negative 2 times b to the power of negative 5 raised to the power of negative 2. Now if we evaluate each one of these things separately, this becomes 1 over 9. Then this, a to the power of 4 to the power of negative 2, will multiply. So that becomes a to the power of negative 8. And if we changed it to positive exponent, it would be 1 over a to the power of 8. And then finally, we'll keep the base b, and then negative 5 times negative 2 gives us positive 10. So basically we have three fractions here being multiplied together. Tops times tops gives us b to the power of 10, and bottoms times bottoms gives us 9, and then a to the power of 8. So in either case you do end up with the exact same answer. Okay, question E. This time we have radicals. So what we're going to do is change each one of these into a fraction in our exponent. We'll keep the base a, and then because of this number being in the front here, I know that's the denominator of our fraction, and this is really a to the power of 1, so that'll be the numerator of our fraction. So our exponent would be a to the power of 1/3, and that's being multiplied by a to the power of, again, numerator and denominator, so 4 over 5. Now that we're at this point, well, we have the same base, so when we have the same base in multiplying, we'll keep the base and then add the exponents. So we can do a little bit of side work over here. We end up with a to the power of 17 over 15. So we'll move ahead now. For question F, basically what I see here is base x in each one of these terms, or each one of these expressions. So I'm going to try and simplify the numerator, and then we'll divide by the denominator. So looking at the numerator, I see a power to another power. So we are going to multiply. This becomes x to the power of 3p plus 3. Okay, whenever you see a square root sign that doesn't have a number here, the default is 2 because it's the square root. Okay, so we'll keep x and its exponent 2p plus 6 and know that this becomes a fraction. That'll be over 2 because of the root sign. Okay, and then finally we have x, and again, power to a power, so I'm going to multiply the p minus 2 times 5. So that becomes 5p minus 10. Okay, so we can simplify the numerator much more. So I'm going to leave the first expression, and then I'm going to simplify the exponents in the second, because 2p plus 6 divided by 2 is really just p plus 3. Now we'll multiply in the numerator, so we'll keep the base and then we'll add the exponents. So 3p plus p gives us 4p, and then 3 plus 3 gives us 6. So we are subtracting because we are dividing with the same base. So I'll keep the x. Now 4p take away 5p gives us negative p, and then 6 take away negative 10 actually gives us positive 16. And that would be our final answer. Okay, so now we'll move on to evaluating. Remember, when you are asked to evaluate, you want to give a numerical answer. We don't want any decimal answers. Okay, and I want to see all your steps because I know your calculator can do all this work, but the marks come from showing all your steps. So we are multiplying base 7 to the power of 3 times base 7 to the power of 5, and then dividing base 7 to the power of 9. So since we have the same base in all cases, I know that I'm going to be adding the exponents 3 plus 5, and then we're going to subtract the exponent 9 because we are multiplying and then dividing. So really, we end up with 7 to the power of negative 1, and if we were to evaluate that, know that because we have a negative exponent, we take the reciprocal and then leave it to the power of positive 1. So 1 over 7 would be our final answer there. Okay, so then we have 64 to the power of 5 over 6. So remember, when you have fractional exponents, you would take the denominator and that would become your root. So we're going to take the 6th root of 64, and then once we're done with that, we can raise it to the power of 5. So the 6th root of 64 is 2 raised to the power of 5, which would give us 32. The other way to do it is if you took the base 64, raised it to the power of 5 first, and then whatever that answer was, you can take the 6th root of that. But if you do it this way, the numbers end up being quite large. The other way you could probably do in your head. Okay, so now we have 27 to the power of negative 4 over 3. So because I have a negative exponent, I'm going to take the reciprocal right away. So this will become 1 over 27 to the power of positive 4 over 3. And then I'm going to realize that because I have a fractional exponent, this becomes the 3rd root of 27. And then once we figure that out, we'll raise it to the power of 4. So I know that the 3rd root of 27 is 3. And then 3 to the power of 4 is 81. And so 1 over 81 would be our final answer. Okay, in question D, we have a fraction that's raised to a negative exponent. So because this is raised to the negative exponent, we can take the reciprocal right away and then raise it to the power of 2. So this would become 3 squared over 2 squared, because the exponent affects not only the numerator but the denominator as well. So our final answer would be 9 over 4. And then again, for our last question for today, we have 81 over 49 raised to the power of negative 1/2. So again, because our fraction, or because our exponent is negative, I'm going to take the reciprocal right away. And then our exponent becomes positive. Notice that the exponent didn't flip. A lot of times I'll see on tests that some people flip the exponent as well. The exponent does not flip. It never flips. Just the sign will change. Okay, so now this becomes 49 to the power of 1/2 over 81 to the power of 1/2. And know that the 2 is associated with the root sign, so this becomes the square root of 49 to the power of 1. And again, the square root of 81 to the power of 1. Now, again, notice that we do not ever write this 2 in front of the square root. It's not necessary. It's kind of like the same idea when we write x, we know that's already raised to the exponent 1. When we write a square root sign, we know that the value here is 2. Okay, in any case, square root of 49 is 7, and the square root of 81 is 9. And we are finished with that question. So that is it for today's lesson, and if you have any questions, please make sure you ask in class. Take care, guys.